In this lesson, we are going to be looking at correlation coefficients, or any correlation that we have. You'll see that the correlation coefficient, the variable is r, which doesn't really make sense, right? You'd think it'd be a c, but it's an r. And what it does is it describes the direction and strength of a linear relationship between two variables. It does not describe it for anything that's not linear, so remember straight lines. And so the direction would be positive or negative. We talked about that before, and the strength could be strong or weak. A positive r has a positive association. So remember, positive association looks this way. So then with that, a negative r would have a negative association. So that would be a negative slope. R, 0r means no association. So if there's no correlation, meaning the data is all over the place, you can't really say if it's positive or negative, something like that. That would be no association if you had a 0r. R's always fall between 1 and negative 1. So there's no such thing as a negative 2 correlation. The closer the values get to 1 or negative 1, the stronger the association. So a decimal of like 0.3 would be weaker than a decimal like 0.7. 0.7 is closer to 1, so that's a stronger association. And then to the negative, negative 0.7 would be stronger than negative 0.3. So the closer we get to 1 or negative 1, the stronger the association, whether positive or negative. Changing the units of measure does not change r. So if we decide to measure something and go from feet to centimeters, that wouldn't change our correlation coefficient. So it's not affected by the unit of measure. Reversing the cause and effect variables does not change r. So let's say, remember we did the one where it was your height and your arm span? So that is my x is height and my y is my arm span. If I change this and I make this arm span and this height, so I switch my x and y around, that would not change my correlation coefficient. That's what they're saying there. So switching those two around doesn't matter. And the correlation is strongly affected by outliers. So a data value, let's say I have this, which would be a strong positive correlation. Having a dot right there would strongly affect my r value. So outliers make a big deal on there. So what we're going to do now is we're going to look at a few pictures and try to match the correlation coefficient. So we have, you'll see, 6 to look at. There are my options, and we're going to label each one. So first of all, you can decide if something has positive or negative correlation. So my negative ones, I think, are right here, and maybe right here, right? So those are negative. Do I have 3 negative numbers up there? I don't, do I? But, oh, I do, just kidding. I do have 3 negative numbers. So when I look at those, I'm going to say which one is very strongly negative. This would be considered a strong correlation. Definitely negative, right? And their dots are all together. So this would be the closest to negative 1. So then I'm going to say this r would be the negative 0.99, because that's almost negative 1. Then I'm going to look at my next strongest negative correlation. My next strongest between the two other ones I have, it's either this one or this one. Well, these dots are closer, so I'm going to say that's my next strongest, so that would be my next number in line. So negative 0.7, we'll call that one. And then my last one that I thought was negative right here would be my last negative number, so negative 0.3. So I've taken care of all of my negatives. So now I'm going to look at my positive correlation. So that's where I think it's going up, right? These all look like that. This one, I'm not really sure if that goes up or down. Look, if I draw a line in there or in here, you can't really tell which way. So which one do you think that is? Hopefully you realize that one would be the one that has no correlation. So my correlation is 0 there. Between my two positive ones then, the one that is a stronger correlation would be closer to 1. So I'm going to say this one is definitely a stronger correlation. Those dots are pretty close together. So that's going to be my r of 0.9, which leaves me an r of 0.5 right here. So hopefully you can if you can match these, you're fine. I'm not going to ask you to draw me a correlation of 0.43 and expect it to be perfect. I want you to be able to kind of look at it and tell, is this strong correlation, weak correlation? Like this 0.5 we might say is a little bit weaker, right? That's a weak correlation. This 0.3, negative 0.3 for sure is weak correlation, right? But then like this one right here is strong. Strong negative correlation, strong positive correlation. Hopefully those made sense to you. If you do want more practice, you'll see there's a website at the bottom of your notes. And they actually have a little app you can do where they play, you match the correlation to the picture. So feel free to do that if you wanted more practice or before a test if you wanted that.